Hello students, Department of Collegiate and Technical Education in the Learning Management System for the third semester students. In the analog communication subject, we are going to discuss about the Unit 5 amplitude modulation and demodulation of session 3. In the previous sessions, we discussed about the basic concepts of electronic communication, block diagram of electronic communication system, types of electronic communication. In the session 1, in the session 2, we discussed the difference between the analog communication and digital communication, as well as we discussed the difference between baseband communication and broadband communication. Now, in the today's discussion, we are going to discuss about modulation, need for the modulation. Yes. In the previous sessions, we discussed about electronic communication system. In that, we discussed about the baseband as well as the broadband communication. In that, we understand that the baseband is nothing but an information signal. That is the original signal that we are going to transmit. So here, we cannot transmit that using only a original signal. We cannot transmit over a long distance. So we need to superimpose that original signal or a modulating signal or an information signal with some carrier. Because the carrier means is a high frequency signal. We need to superimpose with a message signal or a baseband signal. So that we can transmit the information over a long distance. So in this concept of modulation, we need basically the two signals, modulating signal and carrier signal. The modulating signal is one which is also called as a message signal or a baseband signal or an information signal. This is always in low frequency. We can say the audio that we are going to transmit that will be in the range of 20 hertz to 20 kilohertz. So this message information, it always in the low frequency signal. So as we are talking, this low frequency signal, we cannot transmit as it is over a long distance. So we require some high frequency carriers that should be superimposed on this low frequency signal so that we can transmit over a long distance. So for that, we are going for a modulation at the transmitter side, as well as to recover the original signal from the modulated signal. We are going to do a demodulation process that we are going to discuss in our upcoming sessions. Yes, so this is a signal. You can see in the diagram, there's a signal which is a low frequency signal. We can call it as an audio signal or a low information signal or a message signal or a baseband signal. We are going to superimpose that with a high frequency carrier with a certain amplitude and the frequency. Yeah. In the modulation process here, so this is here the low frequency signal. It's a high frequency signal. Suppose we consider here the instantaneous values means here whatever the points is there which is varying with respect to the time is called as the instantaneous values. As we know, the sinusoidal signal will be having some frequency with a certain amplitude and there will be some phase. Okay, so the modulation we can define as a process in which the characteristics usually such as amplitude, frequency, phase of the high frequency carrier is varied in accordance with the instantaneous values of a low frequency information or a modulating signal. So by this definition, we can clearly understand that here the amplitude or frequency or the phase of the carrier signal. Here, suppose we consider this as a high frequency carrier signal, which this high frequency carrier signal is going to vary according to the instantaneous values of the low frequency carrier, the message signal. This is a low frequency message signal. Suppose it is a high frequency carrier, the output will vary like this. For example, we are telling this, we are going to discuss in the next sessions. Yeah, the modulation is the process of superimposing the low frequency signal on a high frequency carrier signal is called modulation. We can give a different definitions like this. Also, we can make a definition. The process of modulation can be defined as varying the radio frequency carrier wave in accordance with the intelligence or information in the low frequency signal. So we can, by this, we can clearly understand that here the amplitude or frequency or the phase of the high frequency carrier wave that can be varied in accordance with the instantaneous values of this message signal. Then we can discuss the what is the need of modulation. So why we have to go for the modulation? As I discussed in the beginning of the session, as a baseband signal, we cannot transmit over a long distance. So we have to go for the modulation by superimposing the high frequency carrier signal with the message signal. So it has some advantages of modulation. What are the advantages? Means we can go through this, like the need for modulation. In the need of modulation, if we do the modulation, the antenna height that can be reduced, and we can avoid the mixing of the signal at the adjacent transmitters. In the transmitters, both transmitters are emitting a same audio frequency signal. There is a chances of interference. There is a chances of mixing of those signals. So that can be avoided by using a modulation. It increases the range of communication. So we can go for the long distance communication, and multiplexing is possible. We can multiplex the signal with a different frequency by using a different frequency carrier frequencies, so that we can transmit in a single channel. That improves the quality of reception. So higher frequency, we are superimposing with the higher frequency signal so that we can improve the quality of reception. Yes. So how it is reducing the height of the antenna? Can discuss this. Here, the transmission of radio signal. The antenna height must be multiple of lambda by 4, where lambda is a wavelength. Like the minimum height of the signal should be a lambda by 4 for any baseband transmission. If it is like that, so the lambda we can calculate by using this formula. Lambda is equal to C by F, and where C is velocity of light and F is minimum height of the antenna must be considered as lambda by 4, where lambda is equal to C by F, where C is the velocity of the light and F is the frequency of signal transmitted. Suppose if there is no modulation, only the base original signal we are going to transmit, means if you are considering audio range frequency, we know there's a 20 hertz to 20 kilohertz. If the frequency we consider as a 10 kilohertz frequency, if we want to transmit, means the lambda becomes, if we substitute the value in C by F equation, so Here, if we substitute the equation in a C by F, where C is a 3 to 10 to the power of 8 and F is 10 kilohertz, the lambda becomes 30 kilometers. The minimum height of the antenna is a lambda by 4. If you take this 30 kilo divided by 4, it becomes 7.5 kilometers. But this height antenna be not at all possible to install. This is impractical. It is impossible to install the height of this particular antenna if we consider a low frequency signal. So if we are going for a modulation, then the frequency become higher. Suppose it is a 10 megahertz, then lambda becomes 300 meters, then the minimum height becomes 75 meters. So this is practically achieved so that the modulation reduces the height of the antenna. Avoids mixing of signal. If the baseband sound signals are transmitted without using a modulation by more than one transmitter, if the similar baseband signal, like the audio signal, whatever you are going to transmit, that is the same audio signal frequency. It is whenever it is going to transmit from this two different transmitters. So those signals, there is a chances of mixing up. So it can we cannot all the signals get mixed together and the receiver cannot separate them from each other. Hence, if we are going for a modulation process, with the different carriers. With the one at the one transmitter, if you are transmitting a signal with a one carrier frequency, in the other transmitter, if you are transmitting with another carrier frequency, then we can multiply that signal and we can transmit over a single channel. So the different channels we can transmit. The modulation avoids the mixing of signals. Next, increasing the range of communication. Here, as we are increasing the strength of the signal, like the frequency, suppose is a 10 kilohertz to around 10 megahertz we are transmitting, means we are increasing the frequency. Here, the power transmitted, actually the one formula we have is a power transmitted is directly proportional to the length. So here, whatever the signal energy, the frequency is increases, the energy of the signal is also going to be increased. So the long distance communication you can use for a long distance communication. You can increase the range of communication. If the transmitted strength is more, that is directly proportional to the square of L. So the length is also going to be increased. Then attenuation reduce, the attenuation is reduced with the increase of the frequency of transmitted signal. So that's what when we are using a modulation, the attenuation is also going to be reduced. Just if you are planning to send a baseband signal, there will be a more attenuation. We cannot transmit over a long distance. If you are using a modulation process, the transmitting power will be increases, so distance can be increased. Multiplexing is possible by using a modulation. So we can combine two or more signals can be transmitted over as a communication channel simultaneously. Next, the multiplexing allows the same channels to be used in a single channel. Hence, so this multiplexing is possible. That's why the TV channel can carry the multiplexed signals. Also, the different frequency signals can be transmitted at the same time. Next, the improves the quality of reception. Here, as the frequency we are going to increase. If you're using a low audio frequency, there's a baseband signal. Here, the energy of the signal will be lower. So, when you are transmitting with a higher frequency, here the energy is going to be boosted. That is, the energy is directly proportional to the frequency. So, that's what here we can improve the quality of the reception because we are increasing the strength of the message signal by adding the high frequency carrier signal. So these are all the advantages of modulations. As we discussed here, these are all the advantages or the need of modulation. It reduces the height of the antenna, it avoids mixing of the signals, and increases the range of communication, and multiplexing is possible in this and improves the quality of receptions. Now, let's discuss the different type of analog modulation technique. Here we understood the concept of modulation. Here, this is a superimposition of the message signal with the high frequency carrier, so that the characteristics of the carrier signal is going to vary in accordance with the message signal. The analog modulation, we have these two types, the continuous wave modulation and pulse modulation. The continuous wave means there will be a sinusoidal signal that we are going to use here for the modulation process. Here in the pulse modulation signal, we are going to use a carrier with a different pulses, with a different height, with a different position, with a different width. So in the continuous wave, as we know, there are the three characteristics: amplitude and angle. So if you are varying the amplitude of the carrier accordance with the instantaneous value of the message signal, then it is called as the amplitude modulation. Here in the angle modulation, again we have the two characteristics, frequency and phase. So depending upon that, we can classify into frequency modulation and phase modulation. In the frequency modulation, the frequency of the carrier is varies in accordance with the message signal. In the phase modulation, the phase of the carrier is vary in accordance with the message signal. In the pulse modulation technique, we have the analog modulation and then digital modulation. In the analog modulation, here we will be having an analog wherein the pulses, that is the different amplitude with the width and position. Here the amplitude, with respect to the amplitude, is the pulse amplitude modulation, and we have the pulse width modulation, and we have the pulse position modulation. In the digital modulation, here the analog signal that we are message signal converted into a digital signal. This is a stream of pulses. So the pulse code modulation will be there. So there will be a delta modulation. These are all the techniques we are used for a digital communication. In the today's discussion, we understood the concept of modulation, what is the need of modulation, and what are the different types of analog modulation techniques. I hope you understood this today's session discussion. Now let's discuss few multiple choice questions. Question number 1. The amplitude modulation is, the options are the change in amplitude of carrier according to the modulating signal, change in frequency of carrier according to the modulating signal, change in amplitude of the modulating signal in accordance with the carrier signal, change in amplitude of carrier according to modulating signal frequency. Answer is A, the change in amplitude of carrier in according to the modulating signal. Modulating signal here nothing but a message signal. Question number 2. Modulation is done in transmitter, radio receiver, between the transmitter and receiver. It's done none of the above. Answer is A, transmitter. The modulation is a process that has always been done at the transmitter side. Question number 3. The amount of data transmitted for a given amount of time is called bandwidth, frequency, noise, and signal power. Answer is A, bandwidth. Question number 4. For the transmission of radio signal, the antenna height must be multiple of dash, where lambda is a wavelength. Options are lambda by 3, B lambda by 2, C lambda by 4, D lambda. Answer is C lambda by 4. This is the minimum height of a radio signal transmission. Question number 5. The modulation process decreases the frequency of the signal to be transmitted. Therefore, it decreases the range of communication. The statement is true or false. Answer is B. It is false. Actually, the modulation process increases the frequency of the signal to be transmitted. Therefore, it increases the range of communication. This is the correct statement. Sixth question. If the amplitude of carrier wave is varied in accordance with the instantaneous value of modulating signal, then such technique is called as options are frequency modulation, B amplitude modulation, C phase modulation, D angle modulation. Answer is B amplitude modulation. Question number 7. If the phase of the high frequency carrier wave is varied in accordance with the instantaneous value of modulating signal, then such technique is called, options are A frequency modulation, B amplitude modulation, C phase modulation, D angle modulation. Answer is C phase modulation. Question 8. Modulation avoids mixing of signal. The statement is true or false. Answer is A, it is true. Question number 9. Indicate the false statement. Modulation is used to, option A, reduce the bandwidth used, option B, separate differing transmission, option C, ensures that intelligence may be transmitted over long distance, D, allows use of practicable antennas. Here, the false statement is reduce the bandwidth used. So in this, B, C, D, all are the correct statements. So these are all the need for the modulation, whereas actually the bandwidth is going to be increased, but they are given here the wrong statement, reduce the bandwidth used. 10th question, demodulation is done in transmitter, B radio receiver, C between transmitter and radio receivers, D none of the above. Answer is B, at the radio receiver. Thank you for hearing the session.